Hey everyone, it's me, Miss B, and in today's video we are looking at the Unit 6, Lesson 8 Cumulative Practice Problems from Illustrative Math Algebra 1. So, first off, we're going to start by making a diagram. So draw a diagram to show that the quantity 2x plus 5 times the quantity x plus 3, that is equivalent to 2x squared plus 11x plus 15. So, that's going to look just like this one down here, but a little bit different. So we're going to make our own because that one actually has an error in it. And we have to figure out later on what that error is. So let's make a rectangle here. I am going to split this into 4 boxes because and not erase chunks of it. I'm going to split it into 4 boxes because I have 2 terms that I need to put along the top and 2 terms I need to put along the side. Along the top here, I'm going to put 2x, and I'm going to put the positive 5. And along the side, we're going to put x, and we're going to put 3. So to show that it's equivalent to this, we're basically showing that the area of this entire thing would add up to that expression. So we multiply each box. 2x times x will make 2x squared. The box to the right is going to be 5 times x, so we will get 5x. The box on the bottom left, we're going to multiply 2x and 3. So 2x times 3 makes 6x. And then the box on the bottom right is 5 times 3, and that is going to make for us 15. So the next thing we're going to do is actually add up our 6x and 5x. So we have 2x squared plus 5x plus 6x plus 15, since all of these are being added up. So that makes the 2x squared plus 11x plus 15. And that is how we would show, using that diagram, that it's equivalent to 2x squared plus 11x plus 15. All right, so that brings us to question 2. Question 2 has us doing a lot more of this multiplication, and we're going to match up A, B, C, and D with the correct answers from 1, 2, 3, and 4. If you want to, you can make a box for each of these, or there's another method that you can do. So first I'll show the box method for this one. Let's make a box. Good enough. We'll move it a little bit. There we go. And divide it up into squares here. So x, and then the plus 2, and x, and then 6. So that would create x squared, 2x, 6x, and 12. Now we are going to have to add 6 and 2 here, so those would make 8x, and that means that A is going to match up with number 4 right here. Now, for B, C, and D, at least for B, I'm going to show you a different way of doing this, and that will be something we'll call double distribute. So I'm going to take the 2x first and distribute it through both of the pieces of my other set of parentheses. So 2x times x will be 2x squared. Then 2x times positive 2 is going to be 4x. The next step we're going to do is take 8 and also distribute it through. But I'm going to draw my lines here on the bottom, make it maybe a little easier to see. So then we'll have 8x and 16. We'll combine the 4x and the 8x here. So we'll get 2x squared plus 12x plus 16, which means that B here matches up with number 3. So you have 2 methods of doing this. You can use the box diagram method, or you can distribute twice. Both of these do the same operation, and then you add the 2 linear terms afterwards. I'll probably write a little bit smaller and just show the box method for C and D underneath these ones, since that is kind of a similar thing That is basically kind of what we learned for this lesson, is to do the box method. So my handwriting will be small, but I got this zoomed in, so hopefully it's not too bad for you to read. So x plus 8 and x plus 4, x squared, 8x, 4x, and 8 times 4, which is 32. So adding up our 8x and 4x, that is going to be, this one here up at the top, because we would get 12x for that piece there. Okay. Oh, and then originally I had this one here. I'll make that a little easier to tell it was coming from that box. So that means that D should go with number 2, but we'll still do the whole thing and check it all out here. So do this one in red. It's kind of just a built-in way to check your answers and see if your answer is one of those 4 options, really. So x plus 2, and then 2x, and a positive 6. So we should get 2x squared. This would be 4x. This will be 6x, and then 2 times 6 is 12. So adding our 4x and 6x would be 10x. So 2x squared plus 10x plus 12. Yep, that is the one that we get here for number 2. So just to write everything out, number 1 goes with C, number 2 goes with D, 3 goes with B, and 4 goes with A, just in case my lines were a little messy or harder to read. That's question 2. So question 3 is more challenging. It's asking us to select all expressions equivalent to x squared plus 4x. So there's a quadratic term and a linear term, but no constant term. And we can do that by actually just doing some distribution here. I'm not going to use the box method, although I may on some of these, but I'm not going to start with it on A. I'm just going to distribute x into each of these pieces here. This makes x squared and 4x. A is one of the expressions equivalent to x squared plus 4x. Now, I'm going to save B and D for a little bit later. We're going to look at E first, C and E first before we do that. So C, I could actually, on this one, I don't actually have to do the box method for this. We could just follow order of operations, and these two could add up to make 2x times x plus 4. So this becomes 2x squared plus 8x, and that is not the same as x squared plus 4x. With E, we can just distribute this one x. Even though it's on the end, we can distribute it through both of these. And we get x squared and 4x. So E also works because that is the expression we're looking for. Now, B and D are very similar, but I will draw your attention to this piece right here. This is the difference between the two of them, is this minus 4. So we're going to start with B, and then we're going to look at what that minus 4 does on the option for D. And this one I will use the box method for, because it might be just like, Ms. Bauman, Ms. B, aren't I allowed to just take that 2 and just square both of these pieces? But actually, we aren't. We have to treat this as something squared is really that same thing, oops, times itself. So this is what we really have, x plus 2 and x plus 2. So that makes x squared 2x, 2x, and 4. And if I add all of those up, it becomes x squared plus 4x plus 4. So B is not a correct answer because we have this extra plus 4 on the end. However, if we did that exact same thing and then subtracted 4, it should leave us with what we want. So I know from showing work on B that this becomes x squared plus 4x plus 4. And then I'm going to have this minus 4 here. And these basically will cancel each other out, leaving us with just this piece. And so D is equivalent. That one's a little tricky, but your answers here are A, D, and E. Question 4 is asking you some questions about the diagram method. So he drew a diagram to expand x plus 5 times 2x plus 3. So we want to explain Tyler's mistake. So Tyler made a mistake, and we're going to look at what he did. So it looks like x plus 5 and 2x plus 3 is what he has. So he got these parts right. That's fine. This part here, that's fine. Let's check his work. 2x times x makes 2x squared. We're good there. 3 times x makes 3x. We're good here. 2x times 5 should make, should make 10x, not 7x. 5 plus 2 makes 7, so I think that's where he made a mistake here. Let's also check the last box. 3 times 5, does not make 8. 3 times 5 makes 15. I think he added again on accident. So Tyler's mistake was he added in the bottom two boxes instead of multiplying. So now they want to know what is the correct expanded form of this. And when we say expanded form, this just means what's the multiplied out version of it. So let's fix Tyler's mistake. Let's use red pen for that. We said, nope, this should be 10x and not 8, but this should be 15. So that would be 2x squared plus 3x plus 10x plus 15. But I have to combine my like terms, so this should be 2x squared plus 13x plus 15. And this is the correct expanded form. That's going to leave us with just some questions on the back, most of which are review or not the new stuff from today. This side with the multiplication of binomials and the box method is from today's lesson. The back here, we have some review from revenue-based things. So based on past concerts, a band has predicted selling this many concert tickets. So 600 minus 10p. When each ticket is sold at p dollars. So actually, instead of underlining, let me highlight these. I like to highlight the number of items. I'm going to use blue, the price. I'm going to use pink for price. And then I like to use green when I'm talking about revenue. So let's highlight where these should go. Number of tickets, that was blue, and ticket price was pink. So they have ticket price, number of tickets, revenue. It first says complete the table to find out how many concert tickets they expect to sell and what revenues they expect to receive at the given ticket prices. So the very first thing I'm going to do is use that expression that's in blue, multiply it out using the numbers that I have here. So starting with 10. I'm going to plug 10 in, P for pink for price. So 10 would go in P here. So 600 minus 10 times 10, that is going to give us 500. 500. 600. I'm going to continue going and do 10 times 15. That will be 450. 600 minus 10 times 20 would be 400. 600 minus 10 times 30 is going to be 300. 600 minus 10 times 35 is going to be 250. And I'm going to keep going from here. 600 minus 10 times 45, 150. Minus 10 times 50 is 100. And finally, at the bottom here, I know that 10 times 60 is 600. So 60 minus 10 times 60, that's 600 minus 600, and this is 0. So what pattern was I doing? I was doing 600 minus 10 times whatever the price was for P. So now, for revenue, revenue is found by multiplying the ticket price and the number of tickets together. So we're going to do that part. I'm going to multiply straight across. So we will do 10 times 500, which is 5,000. 15 times 450, which is 6,750. 20 times 400, which I believe is 8,000. Yes, 1,000. 30 times 300, which I believe, yep, is 9,000. 35 times 250, 8,750. 45 times 150, 6,750. Prices are going back down now. Well, not prices, but the amount of money they're making from these prices. 50 times 100, back to 5,000. And 0 times anything is 0. So if they sold them at $60, no one would buy any and they wouldn't make any money. Now, the very last piece is to fill out in this part what our pattern is. So that is P times 600 minus 10P. We were multiplying those two pieces together. Okay, so continuing on, they want to know, when would they earn no revenue at all? So that is our green column, no revenue. That is, they want to know the price. So at what ticket prices? So at $50 per ticket. Oh, no, not 50, sorry. $60 per ticket is our correct answer here. So question C now says, at what ticket prices? So it's asking us for a ticket price. Should the band sell tickets if they must earn at least $8,000 in revenue? So that's revenue, so it's going to become highlighted green. They want to break even. So if it's at least $8,000, earning $8,000 is okay. We want to earn more. So let's find everything in our revenue column that is $8,000. That I see one right here, highlighted in yellow, 8,000 or more. So 8,000, 9,000, 8,750. Those are the only three numbers that work here. So $20 to $35. $20 to $35. Now, if we actually calculated out $40, I believe $40 would cause us to break even at 8,000, but we want to say just based on our table, so we'll say this based on the table. Okay. Then questions 6 and 7 here are a throwback to Unit 4, I believe. I'm sorry, Unit 5, when we learned about exponential functions. So if something is decreasing exponentially, this is telling us, hey, that is an exponential function. Now, they want us to find the factor of decrease for the bear population. to find the factor, we would take one piece of data and divide it by the previous piece of data. So in this case, I'm going to take two pieces of information here. I'm going to use this piece here, my vertical intercept, and the very next point here. This is, I'll label these. This is 0, 400. And then this one here, since each of these little boxes is counting by 20, this actually becomes 1, 320. So we are going to use 320, and we're going to divide it by 400. This will give you either 4 over 5 or 0.80. Because, well, I guess you can kind of see because I divided those things. If I wasn't showing where I got it from, you would have to explain it. But I'll leave it at that. You can maybe say because you divide one population by the population from the previous year. But part B wants us to use function notation to represent the relationship between the bear population and the number of years since the population was first measured, T. So the bear population is B, and then years since the bear population was first measured is T. We're going to say function notation, this is B of T is going to be equal to, and there are three parts to an exponential function. We're going to start with the initial value, which is how many bears there were to begin with, which is that 400 number. So initial value goes out front, and then our growth factor, or in this case, the factor of decrease. I'm going to use the fraction version, so 4 over 5. You could put the 0.8. Goes inside parentheses, and then that is what gets raised to the exponent. And our exponent is always the variable of our input. And input is almost always time. So that is the equation that represents that. The very last piece we're going to have here is also about exponential functions, but it just wants to know, based on these ones, which ones are exponential. So I'm going to have a couple options, but really what I'm looking for, and what I had mentioned in the first, well, not in the previous one, not the first one, is that in an exponential function, the exponent is your variable. So I want something that involves exponents, but I want the exponent to be a variable. I see that happening here, 2 to the power of m. I see 2 to the power of t. And I see 2/3 to the power of t. So I know for sure that these three are exponential functions. Let's look at the other two, and we can decide whether or not they are. This one, it includes an exponent, but I can just solve that and get an actual number. That actually gives me 8, and then this would just become 8x. So this one here would end up being linear. I'm going to write linear by this one, because this is 8x. And then for D, I see an x squared in there. This is quadratic. So A and D do not work because those are linear and quadratic. So that's it for today's homework. Hopefully my explanations helped, and thank you for sticking with me through this video. This has been the Unit 6, Lesson 8 Cumulative Practice Problems for Illustrative Math, Algebra 1.